You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Avi Loeb. Avi Loeb is the former chair of the astronomy department at Harvard University, founding director of Harvard's Black Hole Initiative, and director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics. He also chairs the board on physics and astronomy at the National Academies and the advisory board for the Breakthrough Starshot Project. He is a member of the President's Council of Advisors on Science and Technology. Loeb is the best-selling author of Extraterrestrial, the First Sign of Intelligent Life Beyond Earth.
Avi Loeb, welcome back to the program.
Thanks for having me.
Now, Doctor, when we last spoke, we were talking about the UAP phenomenon. And of course, many times in the past, we've talked about the idea of alien artifacts in the solar system as a new sort of avenue for SETI. And, you don't find anything if you don't take a look. And if we did take a look and we found an alien artifact within the solar system, it would be one of the most profound discoveries of human history.
Right. We can pretend that we are the smartest kid on the block by closing off the shutters on our windows and not looking out. And that, of course, is a self-fulfilling prophecy, because if we are not searching, we will never find anything. And in principle, we can stay ignorant forever. But that was exactly what was advocated by the philosophers during the days of Galileo Galilei. They refused to look through his telescope and argued that they know that the sun moves around the earth. And then they put him in house arrest so that nobody would listen to what he says. And if he were to live today, they would cancel him on social media. What did that accomplish? They maintained their ignorance. The earth continued to move around the sun. And the same would be true about us not looking through our windows for any potential neighbor that we might have. The neighbor will not go away as a result of us not noticing that neighbor. And of course, you might argue we need extraordinary evidence to even contemplate a neighbor. Well, guess what? If someone knocks on your door and you're not prepared for a neighbor, that would be too late for you to recognize that extraordinary evidence when you open the door. And the role of science is quite fundamental. Science is supposed to educate us about reality, and that is done by collecting evidence. For example, we don't know what most of the matter in the universe is. It's called dark matter. For a lack of a better word, it doesn't interact with light. And so there were all kinds of suggestions for what kind of particles constitute the dark matter, and we've been searching for them, didn't find anything so far, invested hundreds of millions of dollars by searching in the dark. And that is part of the mainstream of astronomy, of science. And I ask, why not search for artifacts of other civilizations? We know that we exist. We know that most stars formed billions of years before the sun. We know that about half of the sun-like stars have a planet the size of the Earth, roughly at the same separation. So it comes without even speculating that it's quite possible that there were civilizations that predated us. They may not be around. We might not have an opportunity to have a phone conversation with them. So looking for radio signals is not the right approach. Instead, what we can do is archaeology. Look for relics that they left behind, equipment. And the way to do that is to survey the sky for objects that look weird. Nothing like the rocks we have seen before in the solar system. And the experience would be very similar to walking on the beach and seeing a plastic bottle among the many rocks that you find out there. And there was such an object that looked weird, called Oumuamua, and I discussed it in my book, Extraterrestrial. I'm not saying that we know for sure that it's artificial in origin, but it's a possibility. And the only way to find out is to find another object on its approach to us, send a spacecraft with a camera, and take a close-up photograph of that object. Because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book.
Now, Project Galileo, the Galileo Project, this aims to answer that question about interstellar objects and things in the solar system, but also to look at things like UAP, which are huge in the news, and get a very high resolution, unambiguous image of one. Now, could you tell us about the sort of three-pronged approach of the Galileo Project?
Right. So I find it quite extraordinary that the US government comes out with a report from the Pentagon to Congress talking about objects they cannot identify, because they're getting paid, the intelligence agencies are getting paid to figure out what flies in our sky. You know, if there is a foreign object, it poses a national security risk. So for them to admit that there are such objects, some of which are real, that we cannot figure out, is an admission in failure. And, you know, that is extremely unusual for the government, which is a very conservative organization. So you hear the government talking about objects we do not identify, we do not know the nature of, that are potentially not human-made. And then the scientific community, which is supposed to be open-minded, blue sky research, contemplating all possibilities, is dismissing it and ignoring it and moving forward as if nothing happened. And that to me is inappropriate, because this subject is sufficiently intriguing now that the government came up with this report for it to move away from the talking points of politicians and national security advisors and military personnel. You won't go to a plumber and ask the plumber to bake you a cake. In much the same way, you won't go to politicians and ask them to explain something we see in the sky. This is the role of scientists. So this subject should move to the realm of science. And the way science operates is by producing evidence that can be reproduced. In other words, placing instruments such as telescopes, cameras, and the data from them being fed to computer systems in a way that is transparent, the data is open. The only reason that much of the government data is classified is because it's taken by classified sensors. So we don't want our adversaries to be aware of the kind of sensors we are using to monitor our sky. And as a result, the data is classified. But if scientists take the data, then it could be open. I mean, there is no restriction on us looking at the sky. We do it all the time as astronomers, except here, instead of looking at distant sources, you would look at the sky and search for nearby sources. You would track them and figure out if they're unusual. Maybe they are just phenomena in the atmosphere of the Earth. At any event, just getting more evidence and analyzing it in the scientific way. So we are advocating looking through new telescopes. And that is exactly what Galilei advocated. And we hope that the Galileo Project, which we named after him, would make far-reaching discoveries, just like Galileo did, that changed our worldview about our place in the universe. So, but even if we don't find evidence for even a single object that came from an extraterrestrial intelligence, we will learn something new. There is no doubt about it, because whenever you collect data in a new way, you find something new. So we might find some atmospheric phenomena that was previously unrecognized, or we might explain all the objects that we see in some simple way. But that would be a contribution, because right now there is this fog of uncertainty, and the public is speculating about the possible interpretation of the Pentagon report. Instead of that, scientists should clear up the fog. And that's what the Galileo Project will do. So with respect to the unidentified aerial phenomena, the UAP that were mentioned in the Pentagon report, the idea would be to place telescopes in many locations, tens to hundreds of telescopes, depending on how much funding we have, and then monitor the sky with the best instrumentation we have, that astronomers have, and then use cameras to get the data and feed it to computers. We can't store all the data. The stream of data would be huge. I mean, most of the data will not be useful. We will just look for objects that move and then track them. So we will analyze it the scientific way and see whether we notice any unusual objects. And then a second part of the Galileo project would be to focus on interstellar objects of the type of Oumuamua that came from outside the solar system and didn't look like a comet or an asteroid that we have seen before from the solar system. So things that look weird, that do not look like rocks, perhaps they're plastic bottles. So that would be the second component of the project. And we will obviously take advantage of data collected by astronomical telescopes, such as the forthcoming Vera Rubin Observatory that will come online in a couple of years, and develop software to analyze the data, and then motivate a space mission to send a spacecraft with a camera that will take a close-up photograph of an object like Oumuamua. And I should say, my dream, for example, in the context of UAP, is if you imagine an object the size of a person, roughly at a distance of a mile, then with a telescope that is a diameter of roughly a meter, you can resolve a megapixel image of that object. In other words, you can see a feature that is the size of the head of a pin. And you can tell the difference between a label that says made in country X here on Earth and a label saying made on planet Y somewhere else. You can tell that. So my hope is to get a megapixel image of an unidentified object and figure out what it is. It's not a philosophical question where we can debate forever whether extraterrestrial civilizations produced objects that visit us. It's a very simple way to apply telescopes and get a high-resolution image of anything that looks unusual and then figure it out. And that's all. And it will just be based on high-quality data that we hope to collect. And of course, there is a third component which goes beyond that talks about other signatures of extraterrestrial technological civilizations that one may hope to get.
In regards to the high-resolution image of a UAP, this has always been a problem because we don't really have very many high-resolution images of this sort of thing, and certainly not high-resolution enough to actually identify them or easily identify them. But my question here is about transparency. So as the Galileo Project moves forward and gets that image, it will immediately go public, right? It'll be... Of
course. I mean, the goal is to, just in the standard scientific tradition, to make the data open to the public and the analysis transparent. So anyone can figure out how we did the analysis, what kind of instruments we've used, is there any concern about artifacts that enter the data, some malfunction of any instrument. It will all be open rather than obsessing with government-owned data because, the government cannot really make the data collection process transparent because, as I said, it involves national security concerns. And the other thing one can do is, of course, control the sensors because if you have a camera on a fighter jet, it would jitter and the fighter jet would move in ways that you cannot necessarily reproduce and take out of the image. And that's why, it's difficult to trust instruments that you do not have full control over. And the other thing is science is not relying on eyewitness testimonies because, human experience could be affected by psychological factors. People may hallucinate, people may have wishful thinking, they might ignore facts that contradict their prejudice or does not flatter their ego. So we don't want to rely on people's impressions. And a lot of the UFO reports of the past do not have high quality data, and it's a mixed bag. Most of the reports may have mundane explanations, but you just need one object that came from an extraterrestrial technological civilization, for this to have a major impact on humanity. We don't need more than one. So if you dismiss hundreds or thousands of reports, that doesn't mean anything. We need to dismiss all of them. If there is one that looks really weird, that could have a huge impact on our understanding.
Well, and it also gets complicated too when looking at the past with past reports of UFOs and accounts. More often than not, the people that actually saw them are dead and can't even be interviewed anymore. So when you're talking about something that may or may not have happened in 1947, there's no one left to talk to them about.
I mean, the other point to emphasize is that science is relying on reproducible evidence, in the sense that, if you repeat the same circumstances, you would see a similar thing. And if you are relying on a one-time event, that does not constitute scientific evidence unless you can find more evidence about that event. So, for example, there was a Big Bang. The universe started from an event, but we can still trace evidence from that event, and therefore we can learn more about it. If it was one event for which the evidence is gone, and therefore you have to rely on a story that was told to you, then it would not be part of science.
No, but what it does do is it may give you insight on where to look. So that you at least have that when somebody says, hey, I saw something over here, look over there. And that's the use of those things. I don't want to marginalize accounts because they can be quite useful.
Exactly. I completely agree. We should learn from past experience. That should guide us. But in terms of figuring out the nature of these objects, the best way to proceed is to collect new data. And, that's pretty much the way kids behave. When kids are told something, they don't listen. They just want to figure out themselves. That's why they get bruised very often. They make mistakes. But scientific inquiry should reflect the same type of curiosity that kids exhibit. And I'm very much driven by that sense that, I want to see the evidence for myself. I don't, okay, there were intriguing reports, but if I do see it through the telescopes that we install in the scientific way, then, that would constitute to me this subject, this evidence being part of the mainstream of science. That would make it publishable in scientific journals, that would allow us to engage in a discussion, just like we discussed the nature of dark matter. And I should say that the most surprising fact for me is I published a book called Extraterrestrial about Oumuamua 6 months ago. I had 1,000 interviews, more than that, since then. And basically almost every day, 5 to 8 interviews and many podcasts. And I wrote commentaries in Scientific American. And some people read my commentary. Some people listened to what I say in the podcast and read my book. And what surprised me is that over the past couple of weeks, donors approached me and I didn't know them. And some of those donors gave the money towards this research project without even telling me. And I had to find out who they are. And so they channeled it through Harvard University. And the point of the matter is that we now have $1.75 million that were donated over the past couple of weeks towards this research project that we define as the Galileo Project. And that's enough for us to demonstrate that we can retrieve very useful data. We can use tens of telescopes with this money and collect the data. And it's not a trivial task. And I have a team of exceptional astronomers that are engaged and are very excited about the opportunity to learn more about UAPs, about interstellar objects like Oumuamua. And altogether, we hope to make discoveries no matter what, irrespective of whether they relate to extraterrestrial civilizations.
I usually don't break the fourth wall, but I want to reiterate to the audience what this actually means. This is a professor of astronomy at Harvard that has the funding to identify the unidentified flying objects fully, publicly, and openly, with data that you can go look at as the project continues, and finally possibly put this all to rest, regardless of the origin. And if we find one that happens to be alien, everything changes. Literally, human. The idea of being human changes. So this is fundamental stuff, and we're going to check in with Dr. Loeb fairly frequently on this as this project develops. Now, Doctor, there is also the idea of looking for satellites of alien origin in polar orbits around Earth. Tell us about that.
Yeah, so it's possible that if I think about interstellar travel, in the old days, people used to think, oh, maybe we will have contact with creatures, with biological living systems. But in my view, Darwinian evolution did not really prepare us for space travel, and we wouldn't survive very long if, in fact, it's not clear that we can make it to Mars because of the cosmic rays that cause a lot of damage to our body, even over a period of a few months of traveling to Mars. And so humans were not really optimized for space travel, and the same is true about any living creatures. But we have another approach, which is we are developing artificial intelligence, and it's already doing things for us, self-driving cars, for example. But within 10 years, we will have systems that outsmart us based on computers, and they will learn from their experience, and you could rely on them, perhaps even more than you can rely on people. And just imagine launching such an AI system, artificial intelligence, into space, coupled with a 3D printer, so that when it gets to a planet, it can reproduce itself. It can make many copies out of the raw materials that it finds on another planet. Then, in much less than 1 billion years, you can pretty much populate all the habitable planets in the Milky Way galaxy with such systems. So it's enough to have one advanced technological civilization in our past that sent out self-reproducing devices equipped with artificial intelligence, 3D printers, and so forth. And the Earth might have such systems moving around. Now, the question is, would we notice? If they outsmart us, the situation might be such that we might need our own artificial intelligence systems to, first of all, figure out that they exist just by analyzing the data we get from the Galileo Project telescopes, and then interpreting their behavior. So relying on our computers to interpret their computers would be similar to relying on our kids to explain to us things we find on the internet, because our kids are more capable. They are better equipped to deal with the internet. And so it's not at all a simple competition, because we had our technologies only for about a century. And what we find may represent technologies that are far more advanced and outsmart us. And we need, first of all, to see if there is anything around us. And second, to try and interpret, if it exists, what is it? What kind of information is it seeking? And the one thing to understand is it takes light 4 years to reach us from the nearest star. And it takes tens of thousands of years to cross the galaxy for light, the fastest moving particles. And that means that there is no way by which a sensor or a probe that is on planet Earth would want to wait for instructions from the sender. The sender may be dead by now, but these systems, if they are sufficiently intelligent, if they have AI, they can work autonomously based on the blueprint that they were provided by the sender. So that, just like with kids, you educate your kids early on in life, and then you send them to the world. And you expect them to behave based on the guiding principles that you equipped them with, such as your rules of ethics, what you find important in life. So you just educate your kids earlier and then send them out. And the same should be true with AI systems. you can train them and give them the blueprint of the kind of behavior that you hope them to follow and the goals that you wish to accomplish. And then you send them out to the world. And then billions of years later, they're on another planet and they're working on their own. And now our question is to figure out what they're after, what they're trying to accomplish.
Now, it's worth reiterating your point here about von Neumann probes and all these ideas of self-replicating technology populating the galaxy. It can actually do it within a time scale of millions of years and fill the entire galaxy with probes, self-replicating probes like this. It's not that big of a deal if you have a lot of time. And who's to say what time an alien civilization has? But this leads us to plausibility of a UAP being of alien origin. It's always been, the argument has always been, well, that it doesn't seem likely because space is just too vast. But that goes away with time. So it shrinks. And there actually is a plausible way, as you mentioned, a probe sitting out there sent in the past sometime, printing out probes that might dip into the Earth's atmosphere. And if someone sees them, they just saw a UAP of alien origin. So right. There is a plausible way.
Right. But the point to keep in mind is, you may ask, we've been leaking radio waves into space for 126 years by now. And they went a distance of 126 light years since Marconi started transmitting radio signals. And then you might say, okay, if there is a civilization out there, how soon should we hear back? So if they send us signal propagating the speed of light, it would take another century for us to hear back. Okay, so in the 22nd century, we might hear back if they're 100 light years away. But if they send a chemically propelled craft, that would take millions of years to reach us at the speed of the New Horizons spacecraft or Voyager. It will take millions of years. So it will take as much time as the time that elapsed since humans appeared on Earth for these crafts to reach us. So we have plenty of time. We leaked our existence, but it might take millions of years for them to arrive physically here. But the point is not that. The point is, we are curious about the stars near us, and at some point we might send spacecraft that will visit those. And it takes much less time than the age of the Milky Way to populate, to get to all the stars in the Milky Way with chemical propulsion. So if they started this project a long time ago of going places, by now they may have reached Earth even without knowing about our existence. It's not in response to what we do. It has nothing to do with us. They already sent it to the habitable planets. And, Enrico Fermi asked this question, where is everybody? Well, perhaps the answer is, they're here. It's just that you were looking for the wrong thing. With better data, you might find them.
And it's worth noting here that Earth has emitted a biosignature because of life on it far longer than we've emitted radio. It has been in an identifiable, strange, obviously habitable exoplanet to someone else for billions of years. And that is well enough time for a civilization that's 10 million years more advanced than we are to have done this project and actually got the entire, is monitoring the entire galaxy, or at least the interesting planets of it. And we ourselves talk about looking for biosignatures and finding life in the universe independent of us. Why wouldn't alien scientists do the same thing?
Right. Now, all I'm saying is we should be open-minded rather than dogmatic, rather than say, we know the answer in advance. We should collect data. And you hear this message from a theoretical astrophysicist. I've written more than 800 scientific papers in theoretical astrophysics. So I pretty much know the theory of almost everything we see in the sky. And nevertheless, I'm advocating getting evidence rather than being trapped in the premise that we already know the answer. And the reason I'm saying that is because of the evidence that there are unusual objects out there. And the evidence came from the interstellar object Oumuamua, and it came from the UAPs that we identify in our atmosphere.
Now, another thing that's worth talking about here is the use of AI in this research, meaning that you can take vast amounts of data, but it seems to me that if you set your AI to sift out things like birds, insects, whatever, and ignore those, it's going to pick up a UAP that is, as they have been reported sometimes, violating the laws of physics. Your AI is going to see that and say, look at this. Another thing would be objects traveling through the solar system on a hyperbolic trajectory like Oumuamua. That seems to be something you could easily pick out using AI. So explain what the use of AI will be here, and versus will all the data itself, the raw data, be available for people to visually look through?
Our data will definitely be available, but data from other systems like the Vera Rubin Observatory will be available through a pipeline that usually astronomers get access to, but it will still be public. And the point is that with AI, with appropriate algorithms, you can look for things that are different from what you've seen before. So just to give you an example, the Pan-STARRS telescope that discovered Oumuamua was primarily looking for objects that will come close to Earth, near Earth objects, because they pose a threat to us. And Congress tasked NASA back in 2004 to find 90% of objects bigger than 140 meters that will potentially collide with Earth. And we're still in the process of doing that. So that was the goal. And as a result, Pan-STARRS was looking for objects moving roughly at the speed of comets or asteroids that come from within the solar system. Then they saw Oumuamua that moved faster, but not a lot faster, maybe within a factor of 2 faster than those typical objects that came from within the solar system. But just imagine an object moving much faster. So, Oumuamua and all the other objects we've seen so far move at a percent of the speed of light. A very small fraction of the speed. But imagine an object moving at 1/10 of the speed of light, or close to the speed of light. Such an object would have probably been missed by existing surveys, because astronomers would see such an object moving so fast that they would say, oh, it must be some artifact in our data processing, or some cosmic ray passing through our camera, or, they would just dismiss it. And with AI, you can do an unbiased analysis. In principle, you can allow searching for all possible speeds, or you can look for things that you haven't expected. And that's the kind of analysis that I hope to do in the context of the Galileo Project. And, it's all about being open-minded. When I was early in my career as a postdoc, I remember looking through the volumes of the Astrophysical Journal, and there was a photograph of a cluster of galaxies that had beautiful arcs of light around it. And at the time, in the mid-1980s, people just didn't care about it. And then it became fashionable to talk about gravitational lensing. And suddenly it was recognized that these arcs of light around clusters of galaxies represent lensed images of background galaxies that are distorted into a ring-like shape. And then, of course, people said, yes, you can measure how much mass the cluster has from looking at the properties of these arcs, giant arcs. But before that, before it became popular, people just ignored them. They appear on all the images that were published in the Astrophysical Journal, and people just ignore them. And so the same thing may have happened to us when we surveyed the sky in the past. There were things that could not have been explained as the typical objects we are looking for. And so people just ignore them. And one important aspect of the Galileo Project would be to look for things that look unusual and try to figure them out.
in regards to using AI to search for this, now, are there other opportunities? For example, people have said maybe artifacts might be located on the moon, where things are going to last for a much longer period. Could we come up with some way to sort of use AI to search the moon for unusual features like that?
Yeah, in principle, you can search images, high-resolution images of the surface of the moon. But the best thing to do is to regard the moon as an archaeological site. So when we establish sustainable base on the moon, we can just go over its surface and look at all the objects that impacted the moon over the past few billion years, because the moon doesn't have any atmosphere that burns them up. So every object that collides with the moon stays on the moon, doesn't burn up. And also there is no geological activity that would mix those objects with the interior of the moon. So by surveying the surface of the moon, you can pretty much find everything that collided with the moon in the past. You can regard it as a museum. Perhaps we will find a spacecraft that we never launched, that came from another planetary system. It's possible.
Now, one thing that strikes me in regards to looking for satellites of alien origin in polar orbit, it seems to me that since we track space debris and we can see, a 2-inch paint chip and track it, if that exists, someone knows about that already, wouldn't you think? And is that data set about space junk something that could be searched and looked for, an object like this there?
In principle, yes. But the problem is we don't have access to that data, and I'm not sure what quality it is. My guess is that the government has the best data possible, but it will not release it. And as I said before, it will be very difficult for scientists to analyze the government data, because even if they do analyze it and they do see the data that is classified, they will not be able to speak about it. So, for example, I think being engaged in the Galileo Project and at the same time getting access to classified data is not a productive path, because then what you know about the classified data would not allow you to speak freely about the unclassified data. And so I'm pretty much approaching this as a scientist that has no knowledge and no access to classified information, and therefore can analyze new data that we obtain with telescopes in an unbiased way, in a free way.
So in other words, by avoiding all government data and completely ignoring it, the Galileo Project does not go under house arrest, as Galileo did.
Well, the only risk comes from the scientific community that will ridicule it and cancel it.
Well, but if it has its own funding, which it's got funding, then does that matter?
No, and I think science should progress irrespective of the biases of the establishment. That's the lesson we learned from Galileo Galilei.
Now, also worth noting here is that this has other objectives, because if you start identifying things and they aren't mundane but they're natural, then we have just found new atmospheric phenomena that we need to understand. Well, think about ball lightning. I mean, that's not the most common thing to see, but this type of a project may be useful in studying that.
Exactly. So you learn something new no matter what. So, for example, in the context of Oumuamua, there were 4 proposals by scientists that said we can explain the anomalies of Oumuamua if we imagine something that we've never seen before, like a hydrogen iceberg, a nitrogen iceberg, a dust bunny, collection of dust particles 100 times less dense than air. And I say, great, let's put all these possibilities on the table, get a high-resolution image of an object like Oumuamua, and see whether it looks like a hydrogen iceberg, nitrogen iceberg, or an artificial object. And the point is, we will learn something new, because if we find a hydrogen iceberg, just as an example, what it means is that was the first object we identified from interstellar space, so it must be very common. And the nurseries that make such objects have nothing to do with planetary systems like the solar system, because the solar system didn't produce hydrogen icebergs. So we learned something extremely important about nature that we've never imagined before. So I say, let's just get more evidence, more data. But if you say, we don't need more data, we pretty much know the answer, it must be some type of rock, it's natural, business as usual, then you are no different than the philosophers that didn't want to look through the telescope of Galileo Galilei. And my point is, science makes progress by paying attention to anomalies, to things that do not quite line up with what you expected. Rather than ridiculing those anomalies and ignoring them, you should be excited by them. And that's what makes science exciting. You might learn something new out of figuring out the nature of things that do not line up with what you expected. That's the way kids behave. They see something new, they want to figure it out.
Where do we go from here with the Galileo Project? What is the first steps to collecting data here?
The first thing is to select the instruments that we will use, meaning what kind of telescopes, what kind of cameras connected to these telescopes, and what kind of computer systems connected to these cameras. And once we select the instruments, the next step is the locations, where to place those instruments. And the reports came from some preferred locations. The question is whether most of the reports have mundane explanations. They are mostly false positives, things that are not really unexplained, but result from our own actions. So in that case, you would be fooled to think that you need to go to those locations because maybe they just represent countries that are technologically developed and therefore have a lot of things flying up. And that's why most of the UFO reports came from those countries. But that's something for us to figure out, whether we want to concentrate in some particular locations or just spread the telescopes evenly at random places. And then, of course, there is the software, which is extremely important, perhaps the most important component of the project, developing the algorithms that will filter out the objects of interest and track them. So that's with respect to UAP. And similarly, you want to develop software that will filter out the data, for example, from the Vera Rubin Observatory in a couple of years. And we look for objects like Oumuamua that on their approach to us so that we can send a spacecraft that will take a close-up photograph of them. Just like we sent OSIRIS-REx to take a photograph of the asteroid Bennu. And it actually landed on it and took a sample that it will return back to Earth in 2023. So just imagine landing on a piece of equipment, doesn't look like a rock, and then importing the technology back to Earth. Entrepreneurs in Silicon Valley would be very excited because it will change their plans. They could make a lot of money out of a technology that is more advanced than what we have right now by thousands of years, millions of years, who knows?
Yeah, especially millions of years. I mean, could we even figure the technology out?
It would look like magic to us. And what I often say is that an advanced technological civilization that has an advanced science and advanced equipment that it produces may look to us like an approximation to God, because we are almost at a point where we can produce life synthetically in the laboratory. And that was a quality that we assigned to God, at least in some religious texts, creating life. And you can imagine in the very distant future, creating a baby universe in the laboratory if we understand quantum mechanics and gravity well enough. So what I'm saying is that perhaps it would look to us so magical that, that it would be overwhelming. We would look at it with awe.
For more information on Oumuamua and specifically how strange it really was, everybody check out Dr. Loeb's new book, Extraterrestrial, link in the description below. And Doctor, I hope you'll come back and give us updates as you collect data and try to identify the unidentified.
It will be my pleasure.
Thanks for listening. I am science fiction author and futurist John Michael Gauthier, currently giving everyone a heads up. We released this week's episode early due to it being active news, so there won't be an episode of Event Horizon this Thursday. However, one of my 10 lists will drop on my original channel that day, And Event Horizon will return to its normal Thursday schedule next week, when I will be joined by Drs. Lisa Kaltenegger and Jackie Faraday for a discussion of what star systems in the nearby part of the Milky Way can see Earth transiting as an exoplanet. See you then.